Hello everyone, welcome to Mentor Buddy. This is your mentor Akhil. Today we are going to discuss the question that is based on permutation and combination, that is PNC. Now, coming directly to the question first, the question says how many different integers can be expressed as the sum of three distinct numbers from the set that is 3, 10, 17, 24, 31, 38, 45 and 52, and the listed options are 8, 56, 16 and 15. Now, in order to solve these kind of questions, we need to have a basic understanding of selection process in permutation and combination. Now, so directly coming to the process of selection, that is the concept of selection. According to the basic understanding of selection, mathematically it can be done by the form that is NCR. So mathematically NCR can be written as n factorial upon n minus r factorial into r factorial. So basically NCR is used for selection, implies in case if I need to select r different bodies out of n different bodies, I'll apply NCR. Now, applying the same logic in one of the simple example. Okay, the example says, let's say there are three circles, that is X, Y and Z. There are three different circles. In how many ways we can select one circle out of these three circles? So basically we need to do a selection of one out of these three. So selection process we simply know can be written as like 3C1. So 3C1 will become 3 factorial upon 3 minus 1 factorial into 1 factorial. This can be further written as like 3 factorial upon 2 factorial. So 3 factorial will become 3 into 2 into 1 and 2 factorial will be 2 into 1. Solving this, 2 will be ruled out and that will be left with only 3. So in three different ways we can do a selection of one object out of these three objects. Similarly, considering let's say there are 4 containers and we need to do a selection of 2 containers out of these 4 containers. The selection of 2 containers is required out of these 4 containers. So we can again simply solve this to be as 4C2. So 4C2 mathematically will become 4 factorial upon 4 minus 2 factorial into 2 factorial. So this can be further expressed as 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. So 2 factorial will be ruled out and 2 factorial is again 2. So 2 cancelled out, so that will become 2 into 3, that will be equals to 6. So in 6 different ways we can select 2 objects out of these 4 objects. Now, applying the same logic of selection in the coming question. The question was how many different integers can be expressed as the sum of these three distinct numbers. So we can see there are total 8 numbers and we need to select 3 numbers out of these 8 numbers. So basically the selection is going to be 8C3, can be solved as 8 factorial upon 8 minus 3 factorial into 3 factorial. So 8 factorial can be written as like 8 into 7 into 6 into 5 factorial, and 8 minus 3 will become again 5 factorial and 3 factorial is 3 into 2 into 1. So this 5 factorial will be ruled out. 3 into 2 will be equals to 6 and we're left with only 8 into 7. So 8 into 7 will be equals to 56. So in 56 different ways we can select these 3 numbers out of the lot of 8 numbers. So in that case answer is going to be option number B, that is 56.